back everyone for another episode of IGCSE Math ZNotes Live. My name is Devan and I am your host for this episode along with our expert Ivan Zelich. So Ivan, please introduce yourself.
Thanks Devon. Welcome back everyone to another IGCSE Math video. So today we'll be getting into coordinate geometry. And for those of you who maybe missed the other videos, I'm a master's student, recently graduated from the University of Cambridge in maths. And I'm very keen to continue taking these lessons. So, without further ado, let's get right into it. Okay, so to unpack, today we'll be, as I said, looking through coordinate geometry, and essentially the main key concepts will be using line equations, so y equals mx plus c, and understanding what they mean, finding midpoints, finding distances between 2 points, using algebra rather than, say, geometry to do that. And we'll be seeing some other things like perpendicular lines, not in the key concepts, but in some of the problems. So I'll explain how that kind of works. Okay, so let's get into it. Okay, gradient. So gradient is the slope of a line. A bigger gradient means the line is steeper, and a smaller gradient means in general the line is not as steep. In general, what's important to know is the gradient is rise over run. So when you have 2 points, it's the change of y on the change of x. Right, and so usually when you're usually given 2 points, at least in a problem, to find the gradient, or you're given a gradient, of course, and then you know that y equals mx plus c, and m is that gradient. So you can then figure out some things in a problem from there. We'll look at it later, but basically, if you have a line with a gradient here, then the line perpendicular to that line has gradient -1 on m. So it kind of goes in the negative and then flips the fraction n. So that's quite interesting, but we'll see more of that later on. Okay, so equations of a straight line, as we said, y equals mx plus c. M is the gradient, c is the y-intercept. So that's useful because usually they ask, where does the line hit the y-axis? That's at the y-intercept, that's at c. So if you have the equation y equals mx plus c, you can easily solve for that type of question. And conversely, if you know what the y-intercept is, then you just can immediately know what c is. So that's quite useful. Pardon me. So midpoint of two coordinates. So when you have 2 points, you can find the midpoint of them. And in general, it's the average of the corresponding coordinates. So as you can see here, x1 plus x2 on 2 and y1 plus y1 2 on 2. And you can find other kinds of points, like say you want a point that's on the third here. You can kind of do it in a similar way by kind of figuring out one way to do it would be to figure out what the distance between these 2 points are, and then figure out then a third of that, and then add in that direction to get what would be like kind of a third of the segment. But you won't experience that in IGCSE, so don't worry about it. But in theory, you could do that. Okay, and we also have the length of a line segment. So this is kind of Pythagoras. Well, it is Pythagoras, basically, in a nutshell. And when you have 2 points, you can draw like a little triangle like this. So if it's this high, y2 from the origin, and y1 from the origin, then the difference is y2 minus y1. And this length here. Similarly, this is x2 minus x1. And then you can just square them and use Pythagoras to find what d is. So we'll be using this quite a bit in the next few questions that we'll see. So getting on to the questions now. So we have a question that says the graphs of y equals x minus 1 squared and y equals half of x plus 1 intersect at A and B. at 2 points. Find the length of A and B. So first we have to find those 2 points. So to find those, to find the intersection points, we basically have a simultaneous equation. We have already kind of singled out y, so we can do substitution, but it's an easy substitution. We just sub in these two equations, set them equal to each other. So in this case, we get x minus 1 squared equals y, which also equals half of x plus 1. So x minus 1 squared equals half of x plus 1. Again, like usual, we expand the equations, and we get x to one side and 0 on the other side because we have a quadratic. As remember from one of the first few lessons how to factorize quadratics. We take it to the cross, and we get remember to expand x minus 1 squared. So s minus 1 squared is x squared minus 2x plus 1. And then take the half of x and the 1 across the other side, and it simplifies to x squared minus 5 on 2x equals 0. And so we can then, when we don't have to do any fancy things here, because there's a common term of x. We just take the x out and we factor the left-hand side, and we get x times x minus 5 on 2 equals 0. And so the two solutions in this case are simply x equals 0 and x equals 5 on 2. Right. So now that we've found the x coordinate, which was basically what we've been doing since in our first few lessons, factorizing quadratic, solving quadratic equations, and substitution, we now need to find what the y coordinates are. So just like in substitution, and we can simply sub back in to the equations we're given. So in general, we choose the easier equation, and it seems like the one without squares might be easier to calculate. So we substitute in the value of x that we have here, so 0 or 5 on 2, into this equation y equals a half x plus 1. And then we get two values for y. It's either 1 or it's either 9 on 4. And because of that, we can find the two intersection points in total, and we write them down. X and y is either 0, 1 or 5 on 2 and 9 on 4. So that's our answer right there. But this is not our answer, sorry. We have to find the length of A and B. So we found the 2 points. Now we have to find the length between the 2 points. And this is Pythagoras' theorem. So we have to find, so recall that the distance between 2 points is the change in x squared plus the change of y squared under the square root. So we can, we have to find the change of x here, which is 5 on 2 minus 0, which is 5 on 2, and 9 on 4 minus 1, which is 5 on 4. And we do that, and we square them, add them together, take the square root, and we get a square root of 125 on 16, which is 15 on 4. And that's our answer. When you get a nice answer like that, you generally should be convinced that it's, well, it feels like, yeah, it's yeah. So, oh wait, sorry, hang on. I think Devan, that this I may
you made a mistake, did you?
Yeah, it should be a square root of 125. So that actually is 5 square root 5 on 4, not 15.
Yeah,
it's
okay. It's okay.
So, yeah. So it's not that nice. This 15 should be 5 square root 5. So we take the 5 out of that 125 because 25 is
125 is 5 cubed, right? Yeah, it's 5 cubed.
Yeah, exactly. Yeah, exactly. That's why I thought it was something nice, and then I just
Okay,
cool.
It's fine. I guess we just assume that it's 5 root 5 over 4. Yep.
Yeah, 5 root 5 on 4. You can I use calculators in this section, Devan, or?
Of course, every paper of IGCSE, you're allowed.
Okay. Yeah, so just literally check. Make sure if you have the time, or if you're doing it, just chug into a calculator rather than making these silly errors like I did. So, yeah, that's really important. But yeah, so it should be 5 root 5 on 4. But the whole process is correct anyway. So
yeah.
Okay. So next question. The equation of a line L is 3x minus 8y plus 20 equals 0. So we need to find the gradient of the line L. Now, gradient is just m. So what we need to do is we need to find it in the form of y equals mx plus c. So this is all what it is a rearranging equation. Right, so what we need to do is we need to take everything to the other side. And so, okay, here, so I made a little error here. So it should be, apologies, today was a very busy day, but basically it should be here. So what we're going to do is we're going to isolate y. So we can take the 3x and the 20 to the other side. We get negative 8y equals negative 3x minus 20. Or indeed, after taking out the negative and dividing by 8, it should be all positives here. So 3x plus 20 on 8. So no minuses there. So the gradient here would be 3 on 8, not negative 3 on 8. So for the next question, obviously, we'll need to continue with this error. However, if we do everything correct, it'll be fine in the exam anyway. So in general, if you make small errors like I've done by just calculating, which you can do, as long as your methods are correct, you won't lose many marks. So don't worry about that. So as I said, it should be 3 on 8, not negative 3 on 8. But the process is you single out y and find what the m is. So m is the coefficient of x in that case. Okay, so now we have to find the coordinates of the point where the line L cuts the y-axis. In this case, as we said, when the line cuts the y-axis, that's the y-intercept. So in this case, from this line, the y-intercept will be negative 20 on 8, which is just negative 5 on 8, and that's the answer. Of course, if you had done it correctly, it should be 5 on 2, because we didn't divide by the negative, but by a small error. But nevertheless, that's how you do it. So once you have the equation, you just have to take C. To find the x, say the question was to find the x-axis intercept. So the general kind of rule is if y equals mx plus c, then when it hits the x-axis, y equals 0. So you sub in y equals 0 and find what the x is. So that'd be just like solving, taking x to one side, solving for x. Okay, cool. So now another question, we have the coordinates of P are negative 3, 8, and the coordinates of Q are 9, negative 2. First question is to calculate the length of PQ. So this is our Pythagoras' formula. Sorry. These animations.
Yeah,
Sorry,
you have to change it.
yeah, ignore this one, this here. So we have to calculate the length of PQ. So recall that the distance between 2 points is found by Pythagoras, the change on x squared plus the change on y squared. The change on x, remember to keep your, it's not too relevant here. When you find the gradient, for example, you need to make sure that you really keep the same orientation of your points. So if you do Q as your x1, x2, say, x1, y1, then your P has to be y1, y2. So y2, x2, sorry, x2, y2. So just make sure that you keep the points in the same way you're taking them from each other. So in this case, we can do 9 minus 3, which is 12, and negative 2 minus 8, which is negative 10, and then square them and add them together. We get 12 squared plus 10 squared, which is 244, and we take the square root of that, and that's not a terribly nice number, but we can take out a 4 from the 244, we get 61. So 2 root 61 is the length between these 2 points. Okay, so now for the next part, unfortunately that arrived first, but we have to find the equation of the line parallel to PQ that passes through the point 6, negative 1. So in general, when a line parallel to a single line has the same gradient. So if 2 lines are parallel, when you calculate the gradients, same gradient. So that's the tool we'll use here, because we already have a point. So so if we know what the gradient is, then we can calculate what the equation of the line through that point is. And we have the equation. We have that it's parallel to PQ. So we do know a gradient. We just have to calculate the gradient between P and Q. So we do that. So the gradient is change in y and change in x. We select Q first and then P. So change in y between Q and P is -2, -8. And the change on x is 9, -3. When we do that, we get -10 on 12, which is -5 on 6. That's the gradient of PQ. Now, the point through 6, -1 will have the same gradient. So we know that the line passing through 6, 1, parallel to the line PQ, also has the gradient, -5 on 6. So that we know that the equation of the line is y equals -5 on 6, x plus c, because m is -5 on 6. Now we also know this extra bit of information that it passes through 6 and -1. That's all we're given. So we substitute those values into the equation. So we substitute 6 for x and -1 for y. So -1 equals -5 plus c, or indeed c equals 4. And hence the equation is y equals mx plus c, which is y equals -5 on 6x plus 4. And you can always check, you can double check that you did your calculations by subbing in 6, -1 into the equation, but in this case we just solved it, so that just verifies that we didn't do anything stupid. Okay, so we'll get a similar question now. So we have to find the equation of the perpendicular bisector of PQ. So the perpendicular bisector of PQ, if P and Q was a horizontal line, the perpendicular bisector would look something like this. And basically, it's the line perpendicular to PQ that hits PQ at the midpoint of PQ. So our strategy will be to first find the equation of this midpoint is, which we put as S, and then we will use the formula for the gradient of a line perpendicular to another line, and using that, we'll then find what the equation of the line is. So we have to first calculate S. So the equation, so when we calculate the midpoint, the equation is the area, the average of the two coordinates. So you take the average of x1, x2, and y1, y2, and that gives you the midpoint. So in this case, the average of the x's is 9 plus -3, which on 2, which is 3, and -2 plus 8 on 2, which is also 3. That's good. So we've calculated the midpoint. It's 3, 3. Now we need to find the equation of the line perpendicular to PQ through S. The gradient of PQ is -5 on 6. Okay, so the gradient of the line perpendicular to PQ is, you basically take negative of 1 on, so the reciprocal of the gradient of PQ. So the reciprocal of the gradient of PQ is the reciprocal of -5 on 6, which is -6 on 5. And then we just take the negative of that. So that ends up with 6 on 5. So we have a gradient and we have a point. So we know the equation of the perpendicular bisector is y equals 6 on 5, x plus c for some c that we have to find. And we know that passes through S. So we substitute in the value for x and y as 3 on 3. And we get 3 equals 18 on 5 plus c. And when you take that away, you get c equals -3 on 5. Therefore, the equation is y equals 6 on 5x minus 3 on 5. And that's it.
Something I forgot to put in the PowerPoint is that the formula for perpendicular gradients. M1
Yeah, yeah,
times M2 is equal to negative 1. I forgot about
yeah,
that.
yeah, yeah. Yeah, don't worry about that. Sorry. So yeah, so as I said, as Devin said, sorry, the product of the two gradients is -1. As I put here, you can also just think of it as -1 of the reciprocal. Sorry, negative of the reciprocal of the gradient of PQ. So the same thing, but yeah, that the formula for perpendicular line is indeed we have the product of the two gradients is -1. So yeah, is should we say anything more about that, Devin, or
I
is
think,
that
yeah, it's already fine.
okay? Cool. Yeah. So I think that's it. So basically, yeah, as Devin said, I will just say that as the first important thing, the product of two lines that are perpendicular, their gradients is -1. We saw coordinate geometry is basically just substitution and solving equations that we've been doing. So we've done those two things, but in geometric scenarios. So as we saw, the last question was to find perpendicular bisectors. Some other questions were to find lines parallel to some other lines through some points, and all these boil down to solving some equations and substitution. So essentially, that's all there is to it. And remember that, be kind of organized when it comes to thinking about how you're going to approach a problem when you get it. And yeah, it should be, given what we've covered, it should be pretty straightforward, these questions.
Okay, so we have one question from the comments. He said that I do not understand how exactly will the perpendicular bisector be that. Should it be 4 by 7? I don't really understand by what's this 4 by 7. Oh, can you head to the last slide?
Yeah.
Let me the last slide. Okay. So he said the last slide -1. 5/6. 4 by 7. May I see the slide before this
Yeah,
one?
sure.
Oh, okay. So I don't think it's 4 by 7 because the can we head to the next slide again?
Yeah.
All right. Thank you. So since the gradient is -5/6, when you take the reciprocal and multiply by negative, you'll get 6/5. So I don't know where 4 by 7 is coming from. So I think, yeah, that's the answer.
Yeah.
So I
So yeah, remember that the product of the gradients is -1, and yeah. So as Devin said, the 5 on 6 negative becomes just 6 on 5. So it becomes 6 on 5
Yep.
adding up, and you take the negative. Yeah.
Yep. So I guess that's it. That's the only question we got from the comment section.
Yeah. If you want to tell us how you got 4 on 7, 4 by 7, then
I'm
you
not
know.
quite sure. I'm sorry,
Yeah,
I'm not quite sure.
just send us a yeah. You can just put it in the Discord, I guess. Yeah.
Okay, so yeah, I guess that's it for today's episode. And thank you everyone for watching for today's episode, and thank you Ivan for being with us today. Don't forget to check out our website, our Instagram page, and also join our Discord server. We'll see you this Friday. Thank you everyone.
Yeah. Thank you.
Goodbye.
Bye.